Welcome to chemistry. So we have lambda, which is we calculate the energy from n is equals to 2 to n is equals to 6, and after that we've calculated the wavelength for the same range, n is equals to 6 to n is equals to 2. Okay, what we do, we have Bohr's relation model. So Bohr's model says that this is what we have. We have negative 218 multiplied by 10 to the power negative 18 joules multiplied by 1 over n squared. So that's the position. From there, so let's use 2. Well, that is equals to the energy. So if you have, let's say, energy 2, that's energy n. From n, so that's going to be final, that's going negative 2.18 multiplied by 10 to the power negative 8 joules, all that multiplied by the inverse of n squared, which is inverse of 2 squared. We multiply, so that's going to be negative 28 divided by, actually not division, it's supposed to be multiplied by, so it's going to be negative 5 4 5 10 to the power negative 19 joules. And then we have where n is equals to 6, so it's the same equation. That's going to be negative 2.18 multiplied by 10 to the power negative 18 joules multiplied by inverse of 6 squared. So that's going to be negative 118 multiplied by 10 to the power negative 8 divided by inverse of 6 squared, which is 36, giving us negative 7,848. Negative, yeah, let's do it again. So negative 2.18 multiplied by 10 to the power negative 8 multiplied by the inverse of 1 over 6 squared. So it's going to be negative 6,06 multiplied by 10 to the power negative 20 joules. So we have 10 power 19 and 10 power negative 20. So we're going to say we're going to put it to the same power, which is negative 19. So negative multiplied by 10. So it's going to be negative 0.606 multiplied by 10 to the exponent 19. So that's going to be change in energy. It's going to be energy final minus energy initial. Remember, this is our final one. N2 is final, and then N6 is equals to initial. So 6 initial, 2 final. And so that means that we have E2 minus E6, and E2 energy 2 give us negative 645 multiplied by 10 to the power negative 19 joules. All that minus, and we also have minus, which is also a negative value, which is negative 0.606 multiplied by 10 to the power exponent 19. So negative 6.606 exponent multiplied by exponent 10 to the exponent 19 joules, and that translates to negative 5.45. Negative times negative is positive, so we're going to take the positive value 0.606, and remember they're all to the same unit, which is 10 to the power negative 19. So that's going to be multiplied by 10 to the power 19 joules, and that translates to, when using a calculator, negative 5.45 plus 0.606 give us negative 4.844. Negative 4.844 multiplied by 10 to the power 19 joules. Okay, so that's what we have, and from there we know that that negative means that it's released. So it's 4.844 multiplied by 10 to the power negative 19 joules released. So that's what was released. And then from there we use the lambda for the wavelength. Coming back to our equation, lambda, that's Planck's constant multiplied by speed constant, the light, Planck constant, we have constant speed of light, we have energy, we have, that's what we calculated recently, and then from there we plug in. So 6,626 multiplied by 10 to the power negative 34, that's joules second, that's for Planck's constant. And then we have to divide it by the energy, which is 4,844 multiplied by 10 to the power negative 19 joules, and multiplied by the constant speed of light is 2,998 multiplied by 10 to the exponent 8 meter per second. And the units cancel out, second, joule, and we're left with the meter. So using a calculator, let us just check what we have. Lambda representing the wavelength, which is going to be 6,626 multiplied by 10 exponent negative 34 multiplied by 2,998 by 10 exponent 8 plus 4, divided by 4,844 gives us exponent 19 gives us 0,000 1 2 3 4 5, another 0 1 2 6 4 1 0 0 8 meter. And then put that in exponential form is 1 2 3 4 5 6 7 8 9. So it's gonna be 10 to the power negative 9. That's nano. So that means now we have 410 nanometer. That's what we have as our answer. And that's it for A. So we need to know, is it visible? So let's say yes, the light is visible. Wavelength will give us a visible light. So remember, we have 410. If it moves that's 410 to 700 nanometer. It's visible. That's the range that is visible to human eyes. And yes, so the color is going to be violet according to that range. 410 gives us to violet. That's it. Thank you so much for watching, and this is your tutor Black Adam. If you have any question, please leave below. Don't forget to follow, subscribe.